Hey everyone, this is Adam Homan tuning in for Interactive Advanced Concept Worksheet 6, Nuclear Bomb. Thankfully, we are not actually creating nuclear bombs this week. We just have the pleasure of explaining, what exactly is happening when one of those goes off. And so, what is occurring in a nuclear bomb basically is nuclear fission. So, some type of element, usually uranium, from one end of a, say, nuclear missile, um, the one end has neutrons in it and is projected towards the opposite. Basically, up here we can see, and here it's called an incident neutron. This is coming from one end of the bomb, making contact with uranium, and this is what initiates the nuclear fission, which, as we know, can create a chain reaction, resulting in the energy release, a massive energy release, which is the devastation that is a nuclear bomb. In the chain reaction, the neutron splits, spare neutrons project further, hit more atoms, and so on and so forth, which is where all the energy is coming from. And so, in the nuclear bomb that we're familiar with, Hiroshima, Nagasaki, uranium 235 was used, which brings me to the necessary components of a nuclear bomb. So there are two isotopes of uranium. Normal uranium 238 can be mined. Uranium ore is what we see here on the right. However, the uranium that makes nuclear bombs what they are is uranium 235. It can very easily begin that chain reaction of nuclear fission, which is why it's so valuable. The ease of the ability for it to start that chain reaction of nuclear fission is why it's the preferred material for nuclear bombs. The difficulty in this is that the majority of uranium found is uranium ore, uranium 238, which is not as easily create those chain reactions of nuclear fission that we have become to know about nuclear bombs. So there are ways to acquire this enriched uranium 235. One of those methods is through centrifuge. The other is taking advantage of, there is a weight difference between uranium 235 and uranium 238. Because uranium 235 weighs slightly less than uranium 238, it can travel at different speeds. And so I found it interesting in the video provided, there were, extreme lengths of tubes where they were taking advantage of this weight difference to trap or, detach or, acquire this uranium 235 out of the majority uranium 238. And so you can imagine, even if there is I can imagine the weight difference is minuscule, but because there is a difference, it would take great lengths to acquire that uranium 235. So just in conclusion, following up, first and foremost, uranium 235, because it's most easily available to start those chain reactions of nuclear fission, it is the preferred item for nuclear bombs. You have to acquire either through the centrifuge system or through tubes and tubes and miles potentially of taking advantage of the weight difference to acquire it. Once you have enough of it, basically in that bomb or missile, you're going to have the bombardment of the uranium from one end propelling forward to the opposite end, making contact with the enriched uranium, creating that nuclear fission and that chain reaction, which is the energy release and what we come to know as the devastation of the nuclear bomb. So that's all I have for this week, nuclear bomb. And this is Adam Homan, and thank you.